Hello learners, I am Rajni Upadhyay. Today we will discuss the topic Broader and Narrower Aims of Mathematics Education at the School Stage. Course Code 504. Aims of Mathematics Education. Mathematics education has its own aims. According to D.El.Ed, it is more useful to know how to mathematize than to know a lot of mathematics. It is echoed in the National Curriculum Framework 2005, developing children's abilities for mathematization. Repeat, mathematization is the main goal of mathematics education. According to George, there are two kinds of aims in mathematics for school education, such as broader and narrower aims. Development of abilities for mathematization is the ultimate goal of mathematics education. But what is mathematization? Literal meaning of the word mathematize is to reduce to or as if to mathematical formulas. In general, the term mathematization refers to the application of concepts, procedures, and methods developed in mathematics to the object of other discipline or at least of other fields of knowledge. One is said to have acquired the ability to mathematize when he and she is able to demonstrate orderly and systematic ways of expressions and behavior with mathematical precision in all his/her activities. Now, what is broader aims? Developing the ability of mathematization, which is regarded as constituting the higher aims of mathematics, includes developing such as ability as problem solving, use of heuristic, estimation and approximation, optimization, use of patterns, visualization, representation, reasoning and proof, making connection, mathematical communication, including developing aesthetic feelings. Now, according to NCERT, as mentioned in page number 46, such a higher or broader aim in mathematics is to develop the child's inner resources to think and reason mathematically, to pursue assumption to their logical conclusion, and to handle abstraction. It includes a way of doing things and the ability and attitude to formulate and solve problems. So let's discuss with first broader aim, and which is problem solving. What is problem solving? Problem solving is an important life skill which suggests a shift from memorization to understanding of concept and ability to apply those in both familiar and unfamiliar situations, whether in daily life problems or in problems given in the textbooks. The problem solving skills includes skills of observation, experimentation, estimation, reasoning, and verification, abstractions, qualifications, analogy, case analysis, reduction to simple situation, even guesses and verification are useful in many problem contexts. The emphasis in this approach is more on the process involved and not just on the product. Good problem solving function on the assumptions that real life problems are open and have more than one solution and hence require the use of reasoning, analysis, etc. for taking appropriate decision. Problem solving activities also help to connect mathematics to the real world. Here I am taking examples of problem solving. Example 1. Suppose the student of class 2nd in a school are given to find the result of 75 plus 29 in as many ways as possible. So let us see how many ways it can be done. This is a question. I repeat again. Suppose the student of class 2nd in a school are given to find the result of 75 plus 29 in as many ways as possible. Let us see how many ways it can be done. So, first method is direct method, and which is direct method, and which is we can directly add 75 plus 29, that makes 104. And we have another method. In second method, what I have done, 75 plus 29, we convert 29 as 30 minus 1. Then we add 75 plus 30 within bracket minus 1. 75 plus 30 makes 105 minus 1 equal 104. In second method, 75 plus 29, here I convert 29 as 30 minus 1. Now, next step, I clubbed all the positive numbers 75 plus 30 within bracket minus 1. 75 plus 30 makes 105 minus 1. So, result is 104. Third method is in the next method, 75 is converted into 74 plus 1 plus 29. Here I add 1 plus 29 as 30 and plus 24. So the result is 104. And the last method which I have mentioned here is in the next method, 75 plus 29 in 25 plus 4 forms, that makes 75 plus 25 makes 100 plus 4, and the result is 104. So in this way you have seen we have applied number of methods to solve a problem. I repeat again, 75 plus 29, when we direct add it, it makes 104. In the next, 75 plus 30 minus 1 equal, we add all the positive together and separate the minus value. 75 plus 30 makes 105 minus 1, that makes the result 104. In my next step, I convert 75 in 74 plus 1 plus 29 equal 1 plus 29 makes 30. When it added with 74, that makes 104. In the last, 75 plus I convert 29 into 25 plus 4. When we add 75 plus 29, that makes 100 plus 4 and the result is 104. So, in all the form, the result is same 104, 104, 104 and 104. So, here we have applied various ways to find the solution. So, all these processes are correct. Therefore, while we are teaching to solve any mathematics problem, we need to recognize the way it can be solved. Let's discuss the example 2. Here, the question is, when we multiply 3 into 6, what is the result? So, the result is 18. Here, when we multiply 3 into 6, that result is 18. In second, to what value should we multiply 3 so that the result become 18? And answer is 6. In the next, when 18 divided by 3, what is the result? And answer is 6. In the next, to what value we should multiply 6 so that answer become 18? And answer is 3. In next, when 18 divided by 6, what is the result? And answer is 3. So, this is example 2. Now, next example is, what is the perimeter of square whose area is 64 centimeters square? So, the question is, what is the perimeter of square whose area is 64 centimeters square? So, let's start. Area of square is equal to 64 centimeters square, which is given. Now, what is the formula of area of square? Is side square equal to 64 centimeters square. So, the side becomes 8 centimeter. Here we need to find out the perimeter. So, perimeter, the formula of perimeter of square is 4 side. Here side is 8. So, place the value and multiply with 4 equal to 32 centimeter. So, the perimeter of square is 32 centimeter. Now, I have another question. In the given diagram, find the area of this complete diagram. For finding the area of diagram, first we need to divide this diagram in proper form. So, here I divided into 2 slots, rectangle 1 and rectangle 2. Dimension given are, this side is 15 centimeter and this is rectangle. In rectangle, opposite sides are equal. So, this side also 15. In the above side, the total side is, dimension is 20 meter. Here I divided into 2 parts, 12 plus 8 meter, that makes 20. So, here we have 2 rectangles, rectangle A or rectangle B, or we can say rectangle 1 and rectangle 2. In rectangle 1, length and breadth is 15 into 12. In rectangle 2, dimension is 6 into 8. So, the total area equal area. So, total area is area of first rectangle plus area of second rectangle. So, total area is area of rectangle first plus area of rectangle second. Area of rectangle, the formula is length into breadth. For first rectangle, dimension is 15 into 12 and for the second is 6 into 8. 15 into 12 makes 180 plus 48. So, the total is 228 meters square. Unit of area is square unit. So, here measurement unit is meter. So, that makes 228 meters square. Now, next is use of heuristic. It is generally believed that mathematics is considered to be exact where one uses the appropriate formula. But one can use alternative processes and interactive methods to solve a problem. As we have already seen that a problem can be solved in more than one ways. When one solves a problem in a way different from the one given in the textbooks, thought to be the only way, he and she feels a sense of discovering the alternative. This encourages the learner to try different hunches for solving the problems. One who uses such heuristic becomes in the long run efficient in solving real life problems. Most scientists, engineers and mathematicians use a big bag of heuristic, a fact carefully hidden by our school textbooks. Here I have an example of heuristic. Statement is the sum of angles of triangle is 180 degree. So here I am going to be represent to prove the statement in two different forms. So the statement is sum of angles of a triangle is 180 degree. Here I have a triangle ABC. In a triangle ABC, angle A, angle B, angle C are angles, and we extend the line BC to the D so that makes angle as an exterior angle in a form of angle ACD. So as per the rule, angle ACD is equal to sum of interior opposite angle, that is angle A plus angle B. So angle A plus angle B equal to angle ACD because exterior angle is equal to sum of interior opposite angle. Now add angle C on both sides, that makes angle A plus angle B plus angle C equal angle ACD plus angle C. Since angle ACD and this complete angle C makes a linear pair and sum of linear pairs is 180 degree, so angle A plus angle B plus angle C is 180 degree. So we have alternate method also to prove the theorem. In this method again we have a triangle ABC. Now cut each angles of a triangle, angle A, angle B and angle C, and placed in a way so that they makes a line. Here I cut angle A, angle B and angle C, and I put it on a line, put in a way to form a line, angle A, angle B and angle C. So, since all angle of triangle when placed adjacent to each other completely fit on a straight line, so their sum is 180 degree. So, by two ways I have proved the theorem, sum of angles of a triangle is 180 degree. Now next is estimation and approximation. Estimating quantities and approximate solution when exact one are not available are considered essential skills required for scientific investigation. When we estimate the total expenditure in organizing a cultural function or approximate time for completing a task, we may not get the right answer, but surely gain advantage of reaching nearer to the solution. In many cases, students use their skills to employ these approximations in solving more complex problems. School mathematics therefore can play a significant role in developing and refining such useful skills which is not found in the textbooks and in our classroom transactions. Here again I am taking an example. Calculate 3.1 multiplied by 8.9. So by estimation 3.1 is convert into 3 and 8.9 as 9. So solution is 27, but accurate from the calculator is 27.59. Optimization. Optimization means utilization of available conditions and resources to the fullest extent, which is never included in the school mathematics curriculum. The skill of optimization helps to examine whether the conditions provided for the solution of a problem are sufficient and whether all the conditions provided can be utilized in solving the problem. Example: Millie wanted to purchase small gifts for 5 young cousins, say A, B, C, D and E, in her relations, and she had rupees 100 with her. Each child shall get rupees 5 more than the immediate younger cousin. How should she distribute so that the amount is fully utilized? And the answer is 10, 15, 20, 25 plus 30. When we added all these values, that makes 100. In above situation, where optimization of available funds is possible under the given condition. Now here I have an activity to verify the identity a plus b whole square equal a square plus b square plus 2ab experimentally. So here we need to prove the identity a plus b complete square equal a square plus b square plus 2ab. First, we cut out of square of sides with different colors. Here, I have a different colors cutouts. First square, the side represents by A. Second square, side represented by B. And a rectangle AB, AB. Now, when we make a larger box, or we can say a square, and assemble it in a way that makes a square, b square, ab, ab. This is square of side A, this is second square of side B, this is first rectangle of AB dimension, and this is second rectangle of again AB dimension. Here this is a square, a big square whose side is A plus B. Here we have seen A plus B whole square equal to A square plus B square plus 2AB. In the next, uses of pattern. How can we use a pattern? This could be understood by the examples. Here we have examples 5, 10, 15 and 20. It is a multiple of 5. Next is 1, 4, 16, 25. It's a squares of natural number. Representation. Modeling situation using quantities, shapes and form is the best use of mathematics. Such representation aid visualization, clarify, essential, help us discard irrelevant information. Here is example of representation. I have a one circle which is divided into 3 parts. When we shade first part, that shows 1 by 3. When we shaded 2 part, that shows 2 by 3. When we shade complete, so that is whole circle, whole part is 3 by 3. Reasoning and proof. Mathematics is based on reasoning and proof. Two persons may have same answer to a particular questions in different ways. Example. Here I have a boxes. Green boxes denotes negative values and white boxes denotes the positive values. So here I have 6 negative boxes and 5 positive boxes. Each boxes cancel by one another. So remaining box is 1. So minus 6 plus 5, that makes minus 1. Making connection. Mathematics has been making connection within mathematics and between mathematics and other subjects of study. Mathematic communication. Precise expressions and unambiguous use of language are important characteristics of mathematics education. Using mathematical symbols, language, operation, etc. makes mathematics more meaningful and systematic. Example, suppose x is 2 times and 52 more than y, and if y is 75, what is x? So here we can precisely express as x equal to 2y plus 52, and here y is 75, put the values and the result is x equal to 202. Now next is narrower aims. We mostly focus on acquisition on some fundamental content area. According to NCF 2005 is explicit in stating that the narrow aims of school mathematics is to develop useful capabilities, particularly those relating to numeracy, numbers, number operation, measurement, decimals and percentages. Major aims of mathematics educations. First, to develop the powers of thinking and reasoning, to solve mathematical problems of daily life, to understand and acquainted with the environment and culture, to prepare the child for various technical and general future professions, to prepare the child for higher study, to develop in the child the power for invention. I would like to conclude my session by saying the higher aim is to develop the child's resources to think and reason mathematically, to pursue assumptions to their logical conclusion, and to handle abstraction. It includes a way of doing things and the ability and the attitude to formulate and solve problems. The narrow aims of school's mathematics is to develop so-called useful capability, particularly those relating to numeracy, number operations, measurement, decimal and percentages. Hope the session was useful. Thank you.